Okay, today we're going to be discussing chemical formulas. Okay, so when we look at a chemical formula, we want to ask the question, how can we tell the number and types of atoms in that chemical formula? We're going to discuss element symbols, which you should be familiar with from our past discussions. Element symbols in a compound, what a subscript and coefficient is, and the other symbols that will be part of a chemical equation. Okay. Well, chemical symbols. Remember that our chemicals are symbolized by 1 to 3 letters. And you can find all these element symbols on the periodic tables of elements. That's all you'll ever see, as far as we know, unless somebody discovers a new element. Okay? And they're symbolized by 1 to 3 letters. And you'll notice that the first letter is capital. If it's capital by itself, that is a chemical symbol. Okay? You'll see some represented by 2 letters, and even some represented by 3 letters, but we're not going to just get into those this year. Okay, the one I would be careful of, and I see come up often, people are confused, is when you see like something like hydrochloric acid written, you have to remember that Cl is the symbol, and it's not hydrogen, carbon, and iodine. Okay, so just be careful about that. Okay, the chemical symbols in a compound. Right, what are they telling us? Well, this compound we know as, we call it water. All right, this one we call carbon dioxide. This is glucose. And this is sodium chloride, which you call salt. Okay, now what is this telling us? Well, this symbol is telling us you have 2 hydrogen atoms. The reason I know it's 2 hydrogen atoms is because there's a subscript after the element it's representing. And a subscript is just a small number that's written slightly below the element symbol. Okay, I'm just going to put that back up. So you have 2 hydrogen atoms here. Oops. And 1 oxygen atom. If there is no subscript, it could be just known that there's 1 atom of that element. You don't necessarily need a subscript there because it's telling you, look, the symbol's there, that's representing 1. So this is H2O. 2 hydrogen, 1 oxygen. Okay? And this is CO2. 1 carbon, okay, and 2 oxygen atoms. Alright, the subscript again indicating the element that it's following. Okay, now this one looks a little crazy. This is called C6H12O6. Like we said, it's glucose. Okay, and in glucose you have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Okay, and in sodium chloride you have 1 sodium atom and 1 chlorine atom. So sodium chloride. But they don't have, like I said, they don't have subscripts because the symbol is enough to tell you that there's at least 1 atom there. Okay. Now, when we talk about subscripts and coefficients, okay, we're going to discuss subscripts. And subscripts are numbers that follow the symbol that it represents. They're usually smaller and slightly below the symbol, which is why it's called a subscript. Okay, it's sub, which means below. Like a submarine is below the water. Okay, so you have a subscript, and that number is below and behind the symbol it represents. Okay, the subscript tells you, the subscript tells you how many atoms of an element are in a compound. Okay. If there's no subscript next to the symbol, like I said before, it means that there is only 1 atom present in the compound, and that's represented by the chemical symbol itself. Okay? The subscripts show the ratio of atoms present in a compound. So, for instance, you had H2O. So, in H2O, this is a pretty simple one to figure out. Okay? There's 2 hydrogen for every 1 oxygen. So, the hydrogen to oxygen ratio is 2 to 1. In a molecule of glucose, the ratio is slightly different. It is 1 to 2 to 1. So for every one carbon, there's 2 hydrogen and 1 oxygen. Okay? And you can see that. You just have to break it down. 6 divided by 6 is 1. 12 divided by 6 is 2. 6 divided by 6 is 1. Alright, so the ratio of carbon to hydrogen to oxygen in a glucose or a simple sugar molecule is 1 to 2 to 1. Okay. Alright, coefficients. Now, a coefficient is simply just a number that's in front of a chemical formula. So you might see things like written like 2H2O, or 4C6H12O6, or 3CO2. What that's saying is, look, we have 2 full molecules of water. So when you have a coefficient, you simply have to multiply all the subscripts of each atom of the compound. So this would be like saying 2 times 2 hydrogen and 2 times 1 oxygen. So in 2 water molecules, you actually have 2 times 2 hydrogen, that equals 4 hydrogen, and 2 times 1 oxygen, which equals 2 oxygen molecules. So in 2 water molecules, you have 4 hydrogen atoms and 2 oxygen atoms. Okay? This one's a little bit more complicated because it's a bigger number, but all it's saying is the same thing. The coefficient is distributed amongst the subscripts, and you multiply the coefficient times the subscript to figure out the number of atoms that are in that many molecules of the compound. Okay? So this would be like saying 4 times 6 carbons would be 24 carbons. All right, and 4 times 12 hydrogens would be 48 hydrogens. And in 4 times 6 oxygens, that would be 24 oxygens. So there's 24 carbon atoms, 48 hydrogen atoms, and 24 oxygen atoms in 4 molecules of glucose. So this coefficient is telling you how many molecules of each compound you have. And if you look at this, this makes sense because remember the ratio is 1 to 2 to 1, carbon, hydrogen, oxygen. 24, 48, 24 is the same thing as 1 to 2 to 1. And the same thing goes with the water up here. It's 2 to 1 hydrogen to oxygen, 4 to 2 is the same thing as 2 to 1. So if we had 3 molecules of carbon dioxide, we distribute the 3 to the invisible 1 of carbon. So you have 3 carbon atoms. And distribute it to the 2 of oxygen, and now we'll get 3 times 2 is 6 oxygen atoms. Okay? So that's how we calculate the number of atoms present in a compound. You simply multiply the subscripts, the coefficient by the subscripts, and add them all together. Okay? So if you wanted to know how many atoms are in this huge glucose, this many glucose molecules, I should say, you would add 24 plus 48 plus 24, which would equal a total of 96 atoms. Okay? In 2 water molecules, you have 4 hydrogen and 2 oxygen, which is 6 atoms. And in 3 carbon dioxide molecules, you have 9 atoms. Okay? Now we're going to discuss the parts of the chemical equation. Okay? Other symbols in the chemical equation include a yields arrow. And the yields arrow simply indicates the direction of the reaction. So many reactions, though, can go in both directions. So sometimes in a chemical equation, you'll see arrows going in opposite directions, which means it goes both ways. All right, the yields arrow actually indicates, says this is what's happening. If you have carbon dioxide and water, and they go through a chemical reaction, they will yield glucose, water, and oxygen. Okay, and yields means it gives way to. Okay. or if you want to think of it differently, it produces. Okay? Now you'll have reactants, products, and byproducts. So the reactants are on the left side or behind the arrow, okay? And the products and byproducts are on the front side of the arrow. So if I wrote a chemical formula down here, and I'm just going to do carbon dioxide plus water yields glucose, water, and oxygen. Alright, so you'll see the and sign, okay? The plus sign simply can be read as and. Okay, so on the back side of the arrow, you have the reactants, which means these two chemicals are reacting with one another, and what is yielded, if that's even a word, or what is produced. Okay, so when you have carbon dioxide and water, and they go through a chemical reaction, they yield or produce the product, which is glucose. All right, this is the product. And in the process of producing that product, they give off what we call byproducts, or sometimes people call them waste products, which is actually great for us because water and oxygen is good for us. So when plants take in carbon dioxide and water, and they produce sugar, which we can use for energy, they give off water and oxygen, which are byproducts that we actually use the oxygen and water to survive, right, or to get the energy out of the glucose. This is an unbalanced equation, and we'll talk about balancing in our next discussion. Okay, so parts of the chemical equation. You have anything behind the arrow. Okay, so if we switch this around, or if the arrow is facing the other way, these would be now the reactants. And these would be the products and byproducts. Oops. And there is an energy source here, okay? And in photosynthesis, if the reaction was producing glucose, the energy source would be the sun. If the reaction was going the other way, where we're using oxygen to get the chemical energy out of a glucose molecule like we do when we run around and we live, okay, the energy given off will be in the form of heat energy, okay? So the arrow, or the yields arrow, basically indicates the direction of the reaction, okay? Please, if you have any questions, write them down. I'd be happy to go over them. I'll be helping you in class while you work on your labs and your activities. So please make sure you take the opportunity to write questions down as you watch these videos. I'll see you tomorrow.